Metal buildings have a reputation for baking in the summer, and that reputation is earned. A metal roof absorbs solar radiation and passes it straight through to the space underneath, which is why so many of these buildings feel like ovens by 2 in the afternoon. But the fix is almost never a bigger air conditioner. There are 7 systems that make a metal home cool itself, and every one of them costs under $500. Several are under $100. 2 of them are completely free. The biggest one on that list drops the temperature at the roof surface by 10 to 30 degrees, and the materials run $100 to $500 if you install it yourself. But it comes with one installation detail that decides everything. Get that detail wrong and the whole thing does effectively nothing. Get it right and it works for 30 years without maintenance. That detail is number 2, and it costs nothing at all. Start with the mechanism, because you cannot fix a problem you have diagnosed wrong, and almost everybody diagnoses this one wrong. Heat moves 3 ways. Conduction is heat traveling through a solid, the way a spoon warms up in a pot. Convection is heat carried by moving air. Radiation is heat traveling as energy across open space, the way the sun warms your face on a cold morning without warming the air between you and it. Insulation is built for conduction. That is what an R value measures how effectively a material resists heat traveling through it. It is a blanket, and blankets are excellent against conducted heat. Now look at what a metal roof actually does. The industry describes metal buildings as highly susceptible to radiant heat gain, and the phrase they use is that these structures often become ovens in the summer months. The steel absorbs intense solar radiation, heats up, and then re-radiates that energy downward into the space below as radiant heat. So, the sun is not conducting into your building, it is radiating into it. Which is why so many people insulate heavily, spend real money doing it, and still sit under an oven at 3 in the afternoon. They bought a blanket to solve a light problem. The R value is doing its job perfectly. Its job just is not the one that needed doing. Radiant heat does not want a blanket. It wants a mirror. That single distinction explains why the cheapest item on this list outperforms thousands of dollars of additional insulation, and why the order you install things in matters as much as what you install. So let us start with the mirror. Number 1 on the list is the radiant barrier, and it is the single highest value item in this video. It is reflective foil, and it works by reflecting rather than resisting. A quality radiant barrier turns away roughly 97% of the radiant heat that strikes it, not slows it. Reflects it, back out through the roof, before it ever becomes a problem inside. The numbers are genuinely small. Materials run 10 to 50 cents per square foot, which puts 1,000 square feet somewhere between $100 and $500 if you install it yourself. Professional installation runs $1.50 to $3 per square foot, so the labor is most of the cost, which is exactly why this is a weekend project rather than a contract. What it delivers: attic. Side temperature reductions of 10 to 30 degrees, and the Department of Energy puts the cooling cost reduction at 5 to 10% in warm, sunny climates. It also does not wear out. A radiant barrier is effectively a one-time purchase, holding its performance for 20 to 30 years, because reflectivity does not degrade the way a material's insulating value can. Now, number 2, and it is free. The air gap. A radiant barrier pressed flat against the surface. It is meant to protect stops working. Not partially, its effectiveness drops to near zero because reflected heat needs somewhere to go. Without an airspace, the heat simply conducts straight through the foil into whatever it is touching, and you have installed a very thin, very expensive piece of nothing. So the barrier goes up with a gap behind it. On a metal roof, The standard method is one-sided foil installed against the deck, with battens creating that space. And never block your soffit or ridge vents. Leave 2 to 3 inches clear at the peak so air can still move. That gap costs nothing, takes no extra time, and separates a system that works for 30 years from money set on fire. If foil is not practical for your building, low emissivity coatings run $250 to $400 and deliver roughly 75 to 80% of the effect. Number 3 is ventilation. And there is a specific rule that governs whether yours is working or merely present. The standard is 1 square foot of net free ventilation area for every 150 square feet of space. If you have a proper vapor barrier in the assembly, that relaxes to 1 square foot per 300. But the number matters less than the split. That ventilation has to be divided roughly 50-50 between intake down low and exhaust up high. Half in, half out. Air enters at the eaves or the low edge, warms, rises along the underside of the roof, and leaves at the peak. That is the entire engine, and it runs on nothing but the fact that hot air goes up. The materials are cheap. Ridge vent runs $7 to $15 per linear foot. Soffit or low intake vent runs $2 to $13 per linear foot. On a modest building, a complete balanced system is a materials bill under $500. Here is the part that surprises people, and it comes straight from the ventilation trade rather than from me. A properly designed passive ridge and soffit system outperforms powered fans at lower cost with zero maintenance and zero operating expense. Powered fans are genuinely useful where a structure physically cannot accommodate adequate passive ventilation or in extreme heat as a supplement. They are not the default answer, and they are usually the expensive answer. For scale, a home spending $2,400 a year on cooling can cut $350 to $600 annually by going from poor ventilation to a balanced passive system. Now the failure mode, and it is the most common mistake in this entire category. Exhaust without intake. If you install a ridge vent, or a fan, or a turbine, and you do not open an equivalent path for air to enter down low, that exhaust still has to pull air from somewhere. So it pulls it through every gap in your ceiling from the conditioned space you just paid to cool. You have built a machine that removes your air conditioning and sends it out through the roof. Number 4 is the turbine vent, and it is the cheapest working part you will ever bolt to a building. You have seen them, the metal mushrooms, spinning on shop roofs and barns. $20 to $100 per unit for the hardware, $65 to $250 installed if somebody else puts it up. What makes them interesting is that they are the only passive vent with moving parts. Every other passive vent is a hole with a cover on it. A turbine spins, and it spins on 2 forces that cost you nothing: wind pushing across the vanes and convection pushing hot air up from below. So it is a fan that has no motor, no wiring, no switch, and no line on your electric bill. Ever. It runs for as long as the building stands, and the only thing it consumes is weather. The condition worth knowing before you buy one. Turbines are most beneficial, where average wind speeds run 5 miles per hour or more. That covers most rural and open sites comfortably. If you are tucked into a hollow or surrounded by heavy tree cover on all sides, a turbine on a still August afternoon is just a hole in your roof with a decoration on top, which, to be fair, is still a functioning passive vent. 2 honest limits. They can be damaged fairly easily by falling debris, so a turbine under a large tree limb is on borrowed time. And they obey the same rule as everything else in this category. A turbine, without matching intake down low, will happily pull air out of your conditioned space instead of out of your roof cavity. Match the intake, then let the wind do the work. Number 5 is the one with 2 million views behind it. Number 5 is the earth tube, and it is the one that turns a metal building into something that genuinely cools itself. Here is the physics it runs on. Go down 6 feet or so and soil temperature stops caring what the weather is doing. It sits near 55 degrees year-round in summer and in January, regardless of whether the air above it is 100 degrees or 20. That reservoir is already on your property. You own it. You have simply never used it. An earth tube is a buried pipe that lets you use it. Air enters at an intake, travels through pipe, surrounded by that 55-degree soil, gives up its heat to the ground along the way, and arrives inside your building considerably cooler than it left. The materials are ordinary: pipe elbows, an intake screen, and a small fan to move air through the run. Somewhere around $300, which is why this concept has been passed around in half a dozen languages with a small number on the thumbnail. Understand what you are actually doing, though. You are not manufacturing cold. You are borrowing a thermal mass the size of your land and returning the heat to it, which is why the running cost is essentially the fan and nothing else. Now the requirements, because this is the one method on the list you can genuinely get wrong. Slope and drainage first. Warm, humid summer air hitting a 55-degree pipe will condense every single time. That water has to run somewhere by design, or it stands in your pipe and becomes a problem you are breathing. Pitch the run and give it a drain. Second, build it sealed and cleanable. You want access to inspect it, and you want no way for groundwater or pests to enter. Third, ask your building department before you dig. Some jurisdictions have real questions about buried air intakes, and radon is a legitimate consideration depending on your geology. That conversation is free, and it belongs before the trench. And this is the one to install before the slab goes down. Retrofitting means excavating around a finished building. Number 6 is shade, and it is the cheapest degrees on this entire list because heat you block outside never has to be removed inside. Everything else in this video handles heat after the sun has already delivered it to your building. Shade prevents the delivery. That is a fundamentally better position to be operating from, and it costs less than any of the hardware. The west face is where it matters most. Morning sun hits at a low angle and the air is still cool. Afternoon sun on a west-facing metal wall arrives when the building has already absorbed heat all day and has nowhere to put it. That is the wall to shade, and shading it is worth more than shading the other 3 combined. The options run from free to modest. Awnings over the west and south openings. An exterior shade structure or a simple ramada standing off the wall, and the standing off matters because you want air moving between the shade and the steel rather than a hot panel pressed against a hot wall. Trees, if you have the patience, which are free and get better every year. Number 7 is the solar-powered exhaust vent at $300 to $500 for the smaller units. And it has one genuinely elegant property. It runs hardest exactly when you need it most. No wiring to run, no switch to remember, no breaker, and nothing on your electric bill. The same sunshine creating the heat load is powering the fan that removes it. When the sun goes behind a cloud, the load drops, and so does the fan. The 2 curves match automatically. I have put it last deliberately, though, and here is why. If your passive ventilation is properly balanced, you may not need it at all. Buy it after the free and cheap items are in place, not before, otherwise you are paying $300 to solve a problem a $2 per linear foot intake vent would have solved. Add all 7 up, and the arithmetic is less frightening than people expect. Done yourself on a modest building, the whole list lands somewhere around $1,000 to $2,000. But almost nobody installs all 7, and almost nobody should. Most people put in 3 or 4 and stop because the returns stack unevenly. So here is the order I would spend in, ranked by degrees per dollar rather than by what is most interesting. Shade first, because it is the cheapest and it prevents heat rather than removing it. Then the radiant barrier with its air gap, because that is the largest single intervention available on a metal building. Then balanced ventilation, intake and exhaust matched, which costs little and runs forever. Then the earth tube, which is the biggest project and the biggest payoff, and which belongs in the plan before your slab if you have that option. The solar vent goes last, if at all. Now the things that actively work against you. A powered attic fan without adequate intake. It will find the easiest air available, and the easiest air in a house is the conditioned air on the other side of your ceiling gaps. You have installed a device that exports your air conditioning. A radiant barrier laid flat with no gap behind it. Near zero effectiveness, full price. Exhaust without intake in any form. Same failure, different hardware. And the largest one, which is not a cooling mistake at all, on a metal building, skipping full closed cell encapsulation while you chase comfort. Warm, humid air reaching bare steel condenses inside the assembly, and you will trade a comfort problem for rust, saturated insulation, and mold you cannot see. Get the envelope sealed properly first. Everything in this video assumes that is already handled. So what does under $500 actually buy you? Not a building that never needs air conditioning anywhere on earth. Anybody promising that has not spent an August in Texas. What it buys is a metal building that stops behaving like a metal building, one that no longer turns the afternoon sun into an oven, and that in mild and moderate climates genuinely coasts through most of the season with very little help. And notice what every single item on this list has in common. Shade blocks heat before it arrives. A radiant barrier reflects it before it enters. Ventilation carries it out before it accumulates. An earth tube hands it to the ground. Not one of these 7 methods cools anything. They intercept heat on its way to becoming your problem. That is the whole principle, and it is why the cheap items outperform expensive ones. Your building does not have a cooling problem. It has a heat gain problem. Once you stop trying to remove heat and start preventing it, the price of comfort collapses. Here is what I want you to do on the next genuinely hot afternoon, and it costs about $20. Get an infrared thermometer, point it at the inside surface of your roof or ceiling, write down the number, then point it at an interior wall that has been in shade all day and write that down too. The difference between those 2 readings is your radiant load measured in your own building on your own worst afternoon. Not a national average, yours. If that gap is small, ventilation is your project. If it is large and on bare metal, it usually is, then the barrier and the air gap are where your money belongs, and you will feel the difference within a day of installing them. Post both numbers in the comments. I read them, and I am curious how wide the spread runs across different roof colors. Next time, the earth tube on its own. How deep, how long, what diameter, and the drainage detail that decides whether it cools your house or grows something in it.